Hello. Um, yeah. As I promised, I will put some tutorials for SAP2000 online, and I probably won't do a detailed good job as the other tutorials online released by the company itself, but I'm trying to kind of go through and hit some useful tips that I think is going to be useful, especially for our class project. Let's get started. So I basically fire it up, and then I maximize it a little bit, and then let's just do a something like similar to the project. I think the most important thing is that when you create a new stuff, if you really want to be kind of creative, you should go to like grid only, because all the others you're pretty much kind of confined of what you can do, but this one is just to give you the grid. And of course you want to make sure that you select the right units. I typically, it's keep inch Fahrenheit, that's typical. So I'll just go with that. Then it'll ask you number of grid lines you want. So for this case, I want to create my model so that it is in the XZ plane. It doesn't really matter which plane you want it to be. It's a plane truss. So, but anyway, we'll just do. Here's where you need to kind of plan it out. Remember, the ideas we have for that project is that you're gonna have something like span, I don't know, like 14 feet or something, and then that thing total height is about 6 feet. I may be wrong with numbers, but anyway, you kind of want to kind of plan ahead and try to create a grid that facilitates your modeling. So you want the grid spacing to be, we just take inches. So how about we just do 6 inches per grid. Although you don't need anything in Y, you just put the same. And then in the X direction, that's the long span. So we need, if we're gonna do like say 12 feet, then we need 24 of those. So we just say, okay, I just get 30 of those. And in the Y, we only need 1. In Z, we're going to go if we're going to go up to like 6 feet, we need 12 of those, but we just say, okay, we just have 15. Then this one doesn't really matter. You click it, and then it'll kind of create that grid for you. When you model, really, this view is not that important, because when you model, you want to kind of draw it. So you want to do the XZ plane, and it's some display. It doesn't display very well, so what I'll do is I'll kind of switch to another graphical mode called Classical Plus. Because what I figured is that those SAP2000 guys, they're not that savvy about developing those viewable programming, so they probably be better off just do something like this. Anyway, this is our grid. You don't need to kind of use every single one of them. Just remember, like, each grid is half a feet. So if you locate our one support at here, another, then it'll be 3 feet away, so it'll be somewhere here. But anyway, nonetheless, we will begin to draw it. Of course, you want to have a piece of paper that you have already drawn it, and then you just transport it into this software. But anyway, the first thing you need to do is you define material. When you get started, you already have like 2 materials by default in there. This one is A992 steel with Fy equals 50 KSI, and this one apparently is concrete. But we don't really need that. We just add new material, and we say, okay, what do? We just A36 steel. then really no need to change those. And in fact, if you don't want the self-weight of the material, you can just put 0 here. And then those are, standard pretty. And oh, this is 36 already. That's pretty good, so we just OK it. So we added that material. Then we OK. And then the next thing is that you can define the section which will do a truss. But in here, you don't really have the truss option. It's all frame, but you can use the frame as a truss, which we'll talk about later. So we'll add new property, and then we kind of go down. We want to just do a square bar, so we just say others, then section designer. You'll see our square bar. Base material will be our steel. Then we go to the section designer, and then we just do a rectangle. Just click on it, it will kind of have this one, and then you right click on it and you can actually modify it. So you see material is this one. It's kind of duplicated assignment, but I don't know why they do that. Yeah, they could program this thing better, but anyway, the X and Y center is like where they're located. It really doesn't matter, I mean, because everything's relative, but what does matter is the height and width. So let's do a 2 by 2 square inch bar. It's pretty big, in fact. So then you OK it. It's kind of teeny tiny. Doesn't really matter because we know we have it. And then we just exit, return, and then we OK it. Now this bar has been created. Okay. So the next step is just actually draw our trusses. To draw a truss, we don't really need to draw like joint, because SAP2000 it'll automatically create joints when we draw the bars. So we say okay, draw the frame and cable elements. Straight frame, yeah. And then we use our square bar. That's the only section we have. Moment releases. Yeah, this is pretty important. That's kind of distinguished between a bar and a frame. So if you have it as pinned, which means it doesn't transfer any moment towards the end of your bar, which makes it a truss. If you do continuous, which we will do later, we'll kind of transform to a rigid connected frame. So we do pinned here. Those are kind of just some saying. So yeah, let's just say okay, we want to kind of go from here. Maybe remember in the homework or in the project, you're only allowed to use a maximum length of 4 feet, so just be aware of that. And let's see, we kind of just want to do something like that, and we know that we're gonna try to hit a center point somewhere here. I don't know for like exact if that's where we're gonna head, but I'll just say okay, see if we want to kind of just head here. Okay, exit. Okay, that's kind of half of our truss. So one thing you can do, you can draw the other half, or you can do the select all, and then there is edit, and there is a replicate, and there's mirror, just like in a AutoCAD, but you see mirror about the plane. This one is XZ, so we got a parallel to Z. The intersection of a plane with XY plane, which means if you do that cross section, where it's gonna intersect with XY plane, which is like the horizontal plane now. So for Y it doesn't really matter. For X you just go with okay, where is it? Let me count. Like 1 feet, 2, 3, 4, 5, 6.5. So you want to do 6.5 and 6.5. I mean, for your project you're going to do 7 feet, but yeah, it's good for illustration here for now. And you know, and then you don't delete it, but anyway. Oh, okay. I made a mistake because this is not 6.5. This is 6.5 feet. So I reverse it and then I select all. Then hopefully I'll do it this time. You got this one, 6.5 times 12. What is that? 6.5 times 12. So it is 72 plus 6. That's 78. Oh. Okay. Here we go. And now you need to add your support at those points. So what you do is that you can just select those 4 because you know they're all gonna be pinned. Joint, restraints. Okay, yeah, this is like pin. So it's 3 transitional but non-rotational. Okay, then you got your pin, and then for this one we said that we want some forces. Where are we now? So we go assign force. You see, this is like a global coordinate system. You can do a local coordinate system for that point if you defined it, but yet just not our concern. So we're gonna do a negative z. Let's do like 1000k, something like that. Because remember, this is steel; it can be pretty strong. Okay, so now you got everything. Then you go to analysis. You can set analysis options. Now you see like all the degree freedoms are available, which means it analyzes this entire thing as a 3D structure, which you know, you can't do that because out of a plane this thing has no support whatsoever. So you need to analyze it in XZ plane. Basically it just get rid of the Y degree freedom, which is the degree freedom in and out of plane, and then get rid of those 2 rotational ones. Okay, and then you do the run analysis. There's always a default model analysis. We don't really care that much, so we run it now. It asks you to save it, so I save it as what I call simple truss. Of course. Okay. After it kind of run it, you know, there's some weird thing happening in the display, but it doesn't really matter. It's kind of divide this into like 2 windows, but I do think they need a better programming when they do the program of the interface. But nonetheless, you now you can see the displacement. Like you only have 1 combination. Scale factor alter, it'll kind of give you something nice. You could go do that. It's kind of depending on which window is active, it'll just display it over there. So you do that. And now if you take a close look, you find out that this one, let me see what's the scale factor. 10. Let's do like 100. Ooh, yeah, something like that. But you know, if you do too much, it kind of distorted the whole thing. 10, 20 or whatever. Okay. And then the good thing about this program is that if you kind of point your mouse over there, it kind of tell you the displacement at each load. Like this one, it's U1 X, U2 Y, U3 Z, so it deflected by about half an inch. And then if you want to know the internal forces, you have the axial force, scaling, things like that. So you can get to the kind of force diagram, and I believe you can see the compression here is negative, and then tension here is positive. And then if you right click on it, and then you can actually get the like the force at each cross section, whatever you want, and you can see the points here. It's also kind of moving as I move along. So I mean, it doesn't really matter for this frame element, but for beam it will. And one other thing that I want to touch on is that you're not gonna try to kind of get this one and then copy it by hand. So what you can do to get all the results outputted is you go to display and show tables. Then there is analysis results. There's joint output and element output. Element, you can select frame, like the element forces. That's probably most important. And then for the joint, you probably will just do displacement and reaction, right? And then you can say, okay, it'll give you this table. And you can do the export all table to Excel, which will give you a Excel summary of the frame ID, like frame ID number 1. The station is, along the length of the frame. Like this is at the first load, this is like in the middle, this is the last load, and then what is the values. So each frame, it gives you 3 stations. You can change it somewhere to give you more, but for this case, I mean, all stations are the same because it's kind of uniform distributed axial load. And then you have the joint reactions, like the joint number 1, 3, and 17, 8, 19. This is the same as what you will program in your own MATLAB program. Like those are the load on numbers, load ID. You can see the F1, 2, 3. That's X, FX, FY, and FZ. That's a reaction. Displacement, I mean, this one's very straightforward. But your question is going to be, okay, that's great, but how do I know which load is which? There's 2 ways to do it. Don't save, down. You can kind of just click it and then right click. You can see this is element number 35, and then if you do this load, your right click on load will only work when it is actually on the load. So this is like, you can see point object 8. That means this is load number 8. This is load number 6. But a more elegant way to do it is that there's labels and labels. So it'll plot the label of the joints and the element, but it won't do it on the deformed configuration. It'll do it in undeformed configuration. And you may want to do it one at a time because it's kind of confusing. And you may also do this shrink object command, which will kind of shrink your object. Just, it's not like shrinking it physically, it just shrink it so that you can see the display or the connection better. See this load number 1, 2, 3, 4, 5. those type of things. The idea is that finally you're gonna compare your SAP 2000 results to your MATLAB programming. If you kind of numbering the your nodes exactly the same as the SAP 2000 numbering, and then numbering your element the same as the SAP 2000 numbering, you're gonna get exact same results. I mean, just to the precision, it should be pretty close. Another thing I want to, the final thing I want to talk about, when you have hundreds of trusses, you only care about the results here and here on this load and this member. You can also do the show table command. So okay, pretty much the same thing, but here selection only, and then you get only that force or element you have. So this tool, especially when you can output it into Excel, it's pretty neat. And then you can go fancy. There's a report setup. You can actually just do a report, let the program generate a report of the analysis by itself. If you want, you can look into those. Those are pretty handy. So that conclude this 2D truss illustration. We're gonna do a 2D frame later. Actually, thinking about doing a 3D frame, but anyway, we'll see. All right, thanks.